Hello and welcome to the first kind of episode in the prep work for A-level maths series. So essentially what this series is going to do is going to cover ideally up to December, so the first term of year 12, and what we're going to do is basically cover everything you're going to learn in that kind of period, and that way when you have those December exams you'll be completely and utterly prepared because you've got a bit of a head start, which means you get higher grades, which means your predicted grades go up, better UCAS applications, and so on. So how is this going to work? Well, I'm going to go through a bunch of questions on each of these topics, and I'm also going to have a kind of worksheet. So I'm going to put all these questions into a PDF. Now, I'm going to put this on the Patreon, but hold on for a second, let me explain why. Basically, with the Google Drive, there were issues with access and people not being able to go on it, different permissions and things like that, and also putting all of those files onto my Google Drive kind of clogs it up. So instead, I'm going to put it on Patreon and with the link in the description, but don't worry, it's completely free. So I've just set it to public view, which basically means you click on the link, you can download the PDF, all totally free, all totally fine. It's just an easier way for me to host it, okay? And what you can do is you can watch through this video, kind of get an understanding for it, and then maybe tomorrow or the day after, you can then attempt the questions yourself, see how much you remember, and practice from there. So essentially this will brush up on all of your GCSE skills that you need, and give you that A-level knowledge as well, so that way when you go to school in September or college, you hit the ground running, you already know most of the stuff, okay? But again, we're going to try and focus on that first term, so that way the first set of proper school exams you're going to do go really well. So that is me blabbering along quite a lot. I'm not going to do this in every single video, but yeah, links in the description for the worksheet. I'd recommend you download and have a go in a day or two. So the first kind of main topic is algebraic expressions, and this includes indices, which you should be fairly familiar with, so questions like this, factorizing, expanding, and rationalizing the denominator. So all stuff that you have done before. However, it is a bit trickier, and these tend to be the first question or two on your actual A-level maths paper. So let's think about what we do with indices. So the first question just says simplify this kind of expression over here, and we have a fraction and we have this 1 over 3. So what I like to do is I like to kind of work outwards and go in. So the only thing actually that's actually going to change this is this to the power of a third. And if you remember, when you have something to the power of a third, so let's say a to the power of 1 over 3, that just means you take the cube root of a. And in general, when you have a to the power of 1 over n, it just means you're taking the nth root of a. So all we need to do is take the cube root of the top and bottom. Now for the numbers, this is really easy, because all we have to do is take the cube root. And again, remember, A-level papers are always calculator, which means you can just use a calculator to work it out. But the cube root of 125 is just 5. And I'm going to do both the numbers first because they're quite easy. And the cube root of 64, again, you can use a calculator if you need to, but the answer is just 4. Okay? And the last thing is we now need to cube root x to the power of 6. So what happens when you cube root an indice? Well, what you do is you essentially divide the two things. So you do 6 divided by 3. So just to write this out fully, we have the cube root of x to the power of 6. So that equals x to the power of 6 divided by 3, so that equals x squared. So 5 over 4 x squared. You normally get 2 marks for these questions. At the beginning of the paper, nice warm up, hopefully fairly easy, but just be careful of making mistakes. Next question. So, and again, also check if you can actually simplify this any further, which of course we can't. Here we have simplify 2x to the power of a half to the power of 3 over 4x squared. Well, the bottom, I'm not going to change that at all. Yet, anyway. And the top, again, we work our way outwards. So from the outwards going inwards. So this cube here is going to times everything inside the bracket. So remember, if you have a bracket, so let's say we have ax to the power of something, to the power of, actually let's leave it as just ax to the power of n. That just equals a to the power of n, x to the power of n. So all we do is we cube the 2, which is obviously going to be, so 2 times 2 is 4 times 2 is 8, so 8, and then x. And what happens when you have powers? Well, again, that means you just times them. So a half times 3 gives me 3 over 2. Okay, perfect. Now what do we do? Well, now we need to actually simplify it. So that gives me the first mark. Nice and easy. 8 and 4, we can divide those both by 4. So divide top and bottom by 4. That would give me 8 divided by 4 is 2. And 4 divided by 4 is just 1. So we're going to leave that for now, because it might just be no fraction at all. And then what happens when you have x divided by another x? Well, when you have x to the power of a divided by x to the power of b, you actually just subtract the powers. So a minus b. So we have 3 over 2. Let me write that a bit clearer for you. We have 3 over 2 divided by, well, minus 2. So that's just going to be x to the power of minus a half. Again, don't be afraid to use your calculator even for basic calculations. In an exam, it's very easy to make a mistake. You guys have seen me make mistakes myself in basic calculations, so just rely on the calculator a little bit. It's completely fine. And that gives us the second mark. Do a couple more of these because this is kind of as complicated as it can get. These next questions, however, are brand new to A-level. You shouldn't have done any of these in your GCSE, probably, unless you maybe did further maths. Okay, so as I said, this one is slightly trickier just because there's more stuff. But again, more stuff doesn't mean anything. So what's first? Well, I always start with a negative if I have a negative. Okay, so my order of operations, so to speak, is I do the negative, then I do the denominator, then I do the numerator. Now, can you do it in any order? Absolutely. You could do it completely backwards. You could do numerator, denominator, and then the minus. It doesn't make a difference. So why do I do it? Well, the minus is because people forget the minus. If you have to keep writing a minus, there's a chance that you might forget it at one point and just not realise. So get rid of the minus first. It's really, really quick and easy. The denominator will always make the numbers smaller, which are easier to deal with. Now, of course, now that we have Mr. Calculator over here, Mr. Casio, not really that relevant which order you do it in. Okay, so you don't have to worry that much. And in fact, you could just put the numbers in the calculator. So what I could do, if I'm being a bit lazy, is I could do 216 over 27 to the power of minus 2/3. That gives me 1 over 4, and then all I have to do is flip these and work out what those are. But again, I like to do a bit more in depth. So minus, what does the minus do? Well, when you have a minus, especially for a fraction, so let's say a over b to the minus 1, that just becomes b over a. And likewise, if you just have, let's say, a to the minus 1, that just gives you 1 over a. Okay, you just take the reciprocal. So that's the first thing I'm going to do. So we have 27y cubed over 216 x to the power of 6. And now we get rid of the negative, so it's to the 2/3. Okay. This one will probably be worth 3 marks, by the way, which is quite handy. But let's just assume for 2 marks for now. But yeah, let's do 1 mark there. Then we take the cube root of the top and bottom. Again, you can just rely on your calculator for this if you really want to. But of course, it's just going to be 3 anyways. So we have 3. And then if you remember what I said about having these powers and taking the roots, what we have here is the cube root of y cubed, which means we divide the powers. So 3 over 3, which of course is just 1. So that just becomes 3y. Over 216 cube rooted. I'm actually not sure what that is. So 6, fair enough. And then again, if we divide those powers, we have 6 divided by 3, so it becomes squared. And again, that's still in brackets because now we need to square it. So that's the next step. Last but not least, we're squaring everything. So 3 squared is 9. Y squared is y squared. 6 squared is 36. X squared squared is x to the 4. Because remember, when you have a power outside the bracket, you multiply. So 2 times 2, which is x to the power 4. Getting good at algebra is going to save your life in all future maths that you do. So year 12, year 13, if you do anything related to maths in university as well. So algebra is critically important. Make sure that you're pretty damn good at it. So obviously the next thing I'm noticing is that I can actually simplify this again. Because 9 and 36 are actually factors of each other. Well, 9 is a factor of 36. So if I divide top and bottom by 9, I just have y squared over 4x to the 4 for my final answer. And remember when I did that trick at the beginning, it told me 1 over 4. So my I know for a fact that that should be part of my fraction. Cool. Not too bad so far. Now, what about these new style of questions? So actually, let me move this slightly. There we are. What about this new style of questions? Well, it's actually kind of the same. It's actually no different. So don't worry too much about that. Now, all we have to do, and it's mainly for things like this as well, we're going to be solving equations later on, okay? But this is a really, really important skill. So before we get on to solving equations, this is normally the first part of a solving equation question, and they give you 1 mark. Remember how I said in A-level maths, they break up questions into maybe 4 or 5 different parts. And the reason why they do that is to take you through the process of answering a question. Instead of having one question that's like 12 marks, you have 5 parts which add up to 12 marks. So, express 9 to the power of 3x plus 2 in the form 3 to the power of y, where y is in the form ax plus b. Well, if you look here, this is already ax plus b. So all they mean is it's a linear equation, right? It has x and a number. So, the only difference is that we have a base of 9. Remember, the base is the number that has an indice, whereas this is a base of 3. So what I'm trying to do is write 9 in terms of 3. Now, 9 in terms of 3, well, you might think 3 times 3, which is the same as doing 3 squared. So let's take this fact and sub it into that. So instead of 9, I now have 3 squared. And remember to use brackets. That's a really important thing here. Okay? That's really, really important. So whenever you sub in these indices, these new ways of kind of working out the maths, you have to use brackets in order to make sure that everything stays proper. Okay? Because people always forget. Everyone says, now I'll remember. And then they forget. And then I laugh at them. Thankfully, that's only in like regular end of unit tests. Now, hopefully they wisen up by the time of the actual exams or the year 12 mocks. But anyway, and remember what happens when we have a power outside a bracket. We multiply these two things, right? So we have 3 to the power of 2 times 3x, which is 6x, and then 2 times 2, which is 4. Now that equals 3 to the power of y, if y equals 6x plus 4. And if you have a look at the form that they're telling us about, ax plus b, well, a is 6, b is 4. They're both constants. That is completely fine. Done. Nice and quick. Normally it's like 1 mark, maybe 2 if you're lucky, if the substitution's a bit more wonky, but normally 1 mark. Boom. Let's do the same thing again. Express 8 this time to the power of 2x minus 5 in the form 2 to the power of y, giving y in the form ax plus b. Again, same thing. 8 can be written as 2 cubed. By the way, this is where a calculator doesn't always help you in kind of A-level maths, right? Because you do have to just know that. It's hard for you to guess that. So then, that means we're going to have 2 cubed, again, in brackets. Please don't make the same mistake that every other student in the universe makes. Put it in brackets. It's how much longer is it actually going to take you? 2 seconds? Your time is not that valuable yet. It will be in the future, though. That means we have 2. Then we have 3 times 2x, because again, remember, we multiply this indice and this indice. Multiply the indices. 3 times 2x is 6x. And 3 times minus 5, that's what I get for trying to jump the gun, is minus 15. Which is equal to 2 to the power of y, where y equals 6x minus 15. Not too bad, right? Not too bad. Cool. Now, this is where things get a bit more interesting, right? They start doing stuff like this. So given that y equals 2 to the power of x, express 4 to the power of x in terms of y, hence or otherwise. You're going to memorize this phrase, hence or otherwise. You'll see it in every maths question. Hence or otherwise, hence or otherwise, hence or otherwise. We're going to what that means in 2 seconds once we finish this pretty okay question. So we have y is equal to 2 to the power of x. And we need to express 4 to the power of x in terms of y. Well, that's a bit of a problem, isn't it? Because it's 4, not 2. Well, again, let's use our brains and what we did here and just change it in terms of 2. So 4 is just equal to 2 squared, which means 4 to the power of x is equal to 2 squared to the power of x. Now, here's where things get interesting. This is the same as writing, obviously, 2 to the power of 2x. Now, that doesn't really help me with this because this is just 2 to the power of x. Well, what you can do with indices is you can actually swap them round. Because 2 times x is the same as x times 2, right? It's commutative. It doesn't make a difference. So I can actually write this as 2 to the power of x squared. Now, I will say that this last step here that I'm doing is not always necessary. As you get better at maths, as you get more used to the algebra, you'll just recognize this is just equal to y squared. But again, I don't expect you to be that good yet because obviously you haven't started yet. But can you see that 2 to the power of x is y? So that means that is just y squared. So again, just to run over that one more time, just to make sure it makes sense. Over here, we have 2 squared to the power of x. And what that means is we have 2 to the power of 2 times x. Now, all I've done is change it to 2 to the power of x times 2. Now, 2 times x is the same as x times 2. That's why I'm allowed to do that. I've just changed the order around. Okay? It's the same as if I had something like, well, 4 plus x is the same as x plus 4. Right? I can swap them round whenever I want. It's just that normally it's not useful. But in this case, it is. So either you recognize that from this part, it equals y squared, or you change it to this and then write that. This way here, the longer way, is more rigorous mathematically, okay? So if I get rid of that, that's the very rigorous mathematical way of doing it. So again, change the 4 into 2 squared. That means that gives you 2 to the power of 2x. And then I'm going to undo what I did, but instead I'm going to put x inside the bracket. Because these two things here, let's write that in blue, are equivalent to each other. It doesn't matter which way round I put it. Okay? If you want to try this out, let's say x was 3. 2 squared cubed should be equal to 2 cubed squared. Right? That's basically what I'm saying. And if we put it into our calculators, now here's the part where I start getting nervous, just in case I'm not right. 64, okay? (64). Same thing, I can just swap it round whenever I want to. By the way, what I just did on my calculator, that came in clutch when I did my A-levels. Because there were things that I didn't remember, certain rules I didn't remember, expressions I didn't remember, which is completely natural because there's so much to learn. I would just try on a calculator. Easy. Things like sign addition rules and stuff, we haven't done that yet. Anyways, so now it says hence or otherwise solve 4 to the power of x minus 6 times 2 to the power of x minus 16. Well, you don't know how to solve that, but what if I put it in terms of y instead? So 4 to the power of x is y squared. Okay, minus 6. 2 to the power of x is equal to y. So that's minus 6y minus 16 equals 0. Now that is something we know how to solve, isn't it? We can solve that. That's fine. That's a quadratic. This is another skill which you need to get good at because you'll use it again and again and again. Okay? There is something called integration that you have in year 12 but mostly in year 13 that uses substitution. This is called substitution. It's super, super important, and it's the only way to solve these questions. So, again, they introduce it in an easier setting to make it harder later on. That's what they do with A-level maths. They introduce you with baby steps, and then they punch you in the face and make you do it in a hard way. So let's solve this. How can we solve this? Well, I'm now going to show you, you don't have to use the quadratic formula, you don't have to factorize. I'm going to show you how to do it on a calculator because we're grown-ups now. If you have this calculator, which I thoroughly recommend, the link's in the description if you want to buy it. I've got the link to Amazon straight away. Go across and go down to equation/func, which is short for function, obviously. Press equals. We're going to solve a polynomial. A polynomial is just something that has x, x squared, x cubed, x4, or anything like that in it. Polynomial degree. The number 2 is for quadratic because it means that the highest power is squared. If I look here, the highest power of y is squared, isn't it? So I press 2. Then all I do is I write in the equation. So of course they've put x squared in the calculator and x in the calculator. Me, I've got y. So what's the number in front of y squared? Well, there's no number, which means it's a 1. What's the number in front of y? Well, it's minus 6. What's the number at the end? Minus 16. Press equals again. x1 is the first solution. So we have y is equal to 8 and y is equal to, equals again, minus 2. Not bad, right? Now, if you keep pressing equals, by the way, you get the minimum part of the function, which is useful when we come into sketching, not useful here, and then you get another minimum. Don't worry about it. Just go back to the calculator, okay? So that's how you can solve quadratics on your calculator instantly, okay? Forget all that quadratic formula and all that stuff. I mean, you still might need to use it, but you don't even need to do that anymore, okay? Cool. So we're done, right? Wrong. We wanted to solve an equation that has x in it. We've solved for y. No good, okay? So, what we have to do now is substitute back in for x. That's the key bit. So with substitution, you sub in, you solve, and then you sub back in again. So instead of y, we now have 2 to the power of x. Okay, now, technically speaking, you can use logarithms to solve this. If you don't know what logarithms are, you'll learn about them in year 12, but towards the end of year 12. So because your tests in December probably won't have logarithms in it, 99% chance they won't have logarithms in it, I'm not going to use logarithms. I'm going to show you how to do it instead. Think about it. 2 to the power of what gives me 8? Well, 3. Boom, one answer. Okay? Again, if you have logarithms, you can use logarithms, but 99% of you will not have learnt logarithms by December, which means it won't be in your test, which means I'm not going to show you that. 2 to the power of x equals minus 2. Here's the key thing. If it equals a negative number, you will never have a solution. Why? Good question. How on earth can I get a negative number? How can I change the sign of a power? You can't. 2 to the power of anything will never give you minus 2. So some people say, what about minus 1? Well, remember, when you have negatives, it makes a fraction. But the fraction is positive. So it doesn't make a difference. Basically, a positive number to the power of anything will never give you minus 2. Okay? Now, if you're using logarithms, you can't use logarithms on negative numbers. So either way, you can't do it. There is no such thing as a log of negative 2 or negative anything. So we won't use that. But if you think about it, 2 to the power of what gives you minus 2? Nothing. So in other words, the only solution we have is this one. Okay? Which is fine. That's totally fine. Okay? Totally fine. So I know you might think, but it's a quadratic, we should have 2 solutions. We do have 2 solutions. We have y is 8 and y is minus 2. For the quadratic, we have 2 answers. But this, my friend, is not a quadratic. So there doesn't have to be 2 answers. So again, quadratic does have 2 answers. The actual equation we wanted to solve isn't quadratic, so it might not have 2 answers. Totally fine. Okay, now have a look at this one. It just says solve this. Interesting, right? That's weird. Well, this, my friends, is probably a 4 or 5 mark question. And again, in this case, this is what it's more likely to be like. So normally they break it down for you. In this case, they don't break anything down for you. Good luck. So, of course, because we have a base of 2, we have 2 to the power of x and 2 to the power of x, what we're definitely going to do is say that y is equal to 2 to the power of x. Now, that makes this really easy. We can just make that y. No need to stress about that. But this thing over here is interesting. However, it's actually not that bad. So we're going to try and write 2 to the power of 2x plus 1 in terms of 2 to the power of x. Now, let's think about what's happening here. Take a second to think. We need to break apart this indice. We need to break it down. Now, this plus 1, how do we normally get a plus 1 in this case? Well, what you would have is you'd have 2 to the power of 2x times 2 to the power of 1. Because remember, what happens when you times 2 bases? You add their powers. So if we're doing this backwards, so again, if I showed you this as a question, you would say the answer is this, because it'd be 2 to the power of 2x plus 1. but sometimes they make you do it backwards. If this was a -1, hypothetically, in this alternate reality, you would have 2 to the power of 2x divided by 2 to the power of 1, right? Because it's minus. So when you have an addition, it means you're timesing. If you have a subtraction, it means you're dividing. So, that's handy so far. Now what about this 2 to the power of 2x? Well, we can use the trick we had over here and make that 2 to the power of... I just realised I'm writing in a different colour. There we are. We can make it 2 to the power of x squared times 2. So that would equal 2y squared. Or if I want to take that a bit more slowly, just in case, we have y squared times 2, which is equal to 2y squared. So this equation here becomes 2y squared minus 5y minus 12 equals 0. And we do the same thing. If you want, pause the video now and try and do that trick on the calculator, or again, you can just come back to it a bit later. Don't worry about it. So menu, go right one, go down to capital A, equation slash func. Polynomial, that just means anything with multiple powers of x in it. And then again, we're doing polynomial degree of 2 because it's squared. Now, the number in front of x squared is 2 in this case. In front of x, again, x and y, they're interchangeable, don't worry about it, is minus 5. Number on the end is minus 12. We get an answer of 4, so we have that y is equal to 4 and y is equal to, press equals again, negative 3 over 2. Cool, now let's go back to menu, go back up, go along here, boom, done, back to normal. Now again, let's sub, now what we've done is we need to now sub back in, so for 2 to the power of x. So 2 to the power of x equals 4, oops, and we have 2 to the power of x equals minus 3 over 2. Now for this one, x is of course just 2, right? 2 squared, 2 to the power of 2 is equal to 4. For this one, there is no answer, because again, it changes sign. Now, I need to preface this. If we had a minus in front of this 2 to the power of x, we could get a negative answer, of course. But, in this case, no. So there you go. Not too bad, right? Not too shabby at all. What about something like this? Well, something like this is actually not as bad. What we can do is actually just get them all into the same base. So 8 can be written as 2 cubed. So what we have here is we have 2 cubed to the power of 2x minus 5 equals 2 to the power of x plus 1. Okay. Now, when we kind of do these powers again, we times the indices. So we have 2x times 3 is 6x, minus 5 times 3 is minus 15, equals 2 to the power of x plus 1. Now, again, this is where logarithms might be used, or you might be tempted to divide this over. Don't need to. You're actually completely fine. However, if you did divide it over, you'd still get the right answer. Let's use our brains for a second. These bases are identical, right? Now, since they're just directly equal to each other, their powers must also be the same, right? I couldn't have something like 2 cubed equals 2 squared, right? That doesn't make any sense. Instead, the powers have to be the same. So, in other words, 6x minus 15 should be the same as x plus 1. So we have 6x minus 15 equals x plus 1. Now we can solve this. Bring the x's to one side, so it's minus x from both sides. We have 5x minus 15 equals 1. Then we add 15 to both sides. 5x equals 16. And then divide both sides by 5. We get x is equal to, you can either say it's 3.2 or you can say it's 16 over 5. Not bad, right? Not too bad. And we have something similar to this. This, again, is quite an interesting question here. So for part A, solve the equation. Again, that should child's play. Absolute joke. Do it in your sleep. Down to right 1. Polynomial degree, again 2 for squared. Type in the values. So in the number in front of x squared is just 1 because there's nothing in front of x squared. Then it's minus 9 for the number in front of x. And lastly, it's plus 8. We get x1 is 8. That's easy. Equals 1. Probably should have guessed that. I mean, you could have factorized that. But that's it. Now look at part B. Now, what you want to do here, and again, keep in mind, the word hence, I can't remember if I actually explained this earlier when it came up. Hence, for all intents and purposes, means using the previous part. Okay? Now it says hence or otherwise, because basically, if I translate that for you, it's using the previous part, or otherwise, solve an equation or do whatever you need to do. Always use the previous part. There's a reason why part A is there, and there's a reason why they wrote the word hence, okay? They're not so mean that they write hence and they're like, you can't actually use part A, good luck. They don't do that. So, I'm going to be using these solutions somehow. Now, that implies that this equation can be written like this equation. And if I have a look, it's remarkably similar, right? The 8 and the 8, the minus 9, the minus 9, and then the 1 and the 1, like the numbers in front of the squares and cubes. And if I have a look, if I say that x equals y to the power of 3 over 2, then these two equations are actually the same. Because I can write y cubed minus 9y to the 3 over 2 plus 8 as minus 9x plus 8. And then how would I get from y cubed, from y to the 3 over 2 to y cubed? Well, I'd square it, wouldn't I? Because x squared would equal y to the power of 3 over 2 squared. And what happens when you have that? You times it. What's 3 over 2 times 2? It's 3. So that's just x squared. So if you notice, these two things can be written exactly the same. So all I need to do is solve this bottom equation. But I've solved it. It's part A. So it's already done. So we have the solutions of x equals 8 and x equals 1. Now we just need to substitute back in for y to the power of 3 over 2. So we have y to the power of 3 over 2 equals 8. And y to the power of 3 over 2 equals 1. So how do you start working this out? Well, all you need to do is to get rid of the over 2 in the indices, you're going to square both sides. Okay? So that would become y to the 3 over 2 squared equals 8 squared. So timesing those, you get y cubed equals 64. And then you're going to cube root both sides. So you have the cube root of, let's continue it over here just to make it a bit more clean. Then we'll have the cube root of y cubed equals the cube root of 64, which is 4. So then you just have y is equal to 4, right? And for the other one, y to the power of 3 over 2 equals 1, there's a little trick you're going to learn, and that's that if you have an indice and it equals to 1, the answer is always going to equal 1. So if we square both sides, we have y cubed equals 1 squared, which is 1, and then cube root both sides, y is equal to 1. Now, if you noticed, I did these two slightly differently. In this case, where I did the y to 3 over 2 equals 8, I did it really rigorously. So I did each step individually. However, I'm going to highlight that these steps here, most students don't do. Okay? And that's completely fine. I just wanted to show you once what it looks like. So why you have to square and then cube root. But if you notice for this side, I didn't do those intermediate steps because I think it's becoming a bit more obvious, right? You just do the opposite of whatever the bottom is. So this is square root, so you square both sides. This is cube, so you cube root both sides, okay? But again, I showed you once rigorously just so you can see that yourself, okay? Cool. What about factorizing? Well, factorizing is good fun, isn't it? So factorizing completely just means you need to make sure you can't take anything out. So in this case, we have x and x cubed. So I'm going to take out an x. And what about 75 and 12? Is there anything common between them? Well, one way you can check, by the way, is if we get our calculators out, go back to menu, go up to 1. If we do 75 over 12, our calculator simplifies for us to 25 and 4. So I know I can actually take out a 3, right? Because to get from 75 to 25, I've divided by 3. To get from 12 to this, I've divided by 3. So that's a quick way you can check if you can factorize anything out. So we have 3, and on the inside we're going to have exactly what it says. 25, because 3x times 25 gives me 75x. And then we're going to have minus 4x squared, because again, 3 times 4 gives me the 12. And then we have 1x, but we need x cubed, so we need 2 more x's on the inside. Not too shabby. Now, of course, we can actually factorize this even more using the difference of 2 squares. So I'm going to write this out again, but I'm going to put minus 4x squared plus 25 out front. So yeah, difference of 2 squares, what does that mean? Well, if I know what I noticed is that obviously this first thing is a square number, right? 4 is a square number, x squared is a squared number. And 25 is also a square number. So all you do, quite simply, is you square root both of these values and put them into brackets. So all I'm going to do is, if I square root 4, I can have plus 2x, or I can have minus 2x, right? Those are my two options. And then we still have the plus 5 and the plus 5. The reason why I didn't do plus 5 and minus 5 is because I know that it has to times to give me plus 25. The thing that actually has opposite signs is the minus 4x squared. Hence why the 2x is the thing that changes sign between them. But all I've done is I've square rooted 4x squared to get 2x and minus 2x. And I've square rooted the 25 to get 5. That's it. Not too bad. So moving swiftly on to expanding triple brackets. Yes, new shirt, can't hurt. When we expand triple brackets, all you need to do is select 2 brackets and expand those, and then simplify, and then expand again and simplify. Long, tedious, and very prone to mistakes, so be very rigorous. So if I say I'm going to set the first one to just stay the same for now, I'm just going to expand the second set of brackets. Now, x times x will obviously give me x squared. Now you can shorten this a bit, because you should know that 2 times x is 2x, minus 3 times x is minus 3x. So 2x minus 3x gives me minus x. If you do that the longer way, you should find that you get the same answer. And then 2 times minus 3 is minus 6. So I don't need to simplify that, which saves me a bit of time. And now everything in this first bracket needs to times everything in the second bracket. So if you have a look, we have 2 things in the first bracket and 3 in the last bracket. So in total, we're going to have 6 multiplications we're doing. 6 terms. Because 2x times 1, 2, 3 things, minus 1 times 1, 2, 3 things. Okay? The reason why I emphasize that is because in an exam you can check if you've kind of done the right thing by just counting how many terms you have. So 2x times x squared, well 2 times 1 is 2. X times x squared, we'll just add the powers, gives me x cubed. 2x times minus x, well 2 times minus 1 is minus 2. X times x is x squared. 2x times minus 6, well 2 times minus 6 is minus 12. And x. So there you go, we've done the first thing because we have 3 terms, which means we've done this first one. So you can even like tick it off a little bit. Okay, so we've done that first one. Now minus 1 times x squared gives me minus x squared. Minus 1 times minus x will give me plus x. And minus 1 times minus 6 gives me plus 6. So I know some people like drawing the little lines. That works for 2 brackets really nicely. But when you have kind of 2 brackets but multiple terms, you can get a bit messy drawing all those lines sometimes. That's why I don't do it. And now what you're doing is collecting the like terms. Now with practice, this is going to become second nature. Because when you expand triple brackets, you only have 1 x cubed term. You always have 2 x squared terms. You always have 2 x terms. And you always have 1 number term at the end. So again, the x cubed and the number term will always stay the same, guaranteed. But you're going to have 2 lots of x squared, 2 lots of x. Guaranteed, okay? But again, if you're ever unsure, just kind of go in descending powers, right? So if I look at x cubes, do I have any other x cubes? Nope, so I'm just going to write the exact same thing again. And again, sometimes I like to just tick off things as I go along. Look at the x squareds. So we have minus 2x squared and we have minus x squared. So minus 2x squared minus another x squared. So minus 1 is minus 3x squared. So boom, boom. Look at the x's. Minus 12x plus x minus 12 plus 1 is minus 11x. And lastly, we have the plus 6 on the end. Okay. So at the end, we should have 4 terms always when you expand triple brackets, okay? Which we do, so that's really nice. Perfect. Well, actually, you won't always have that necessarily because it could have like a 0x and a 0 number, right? But anyways. Perfect. So hopefully that all makes sense. Now, here is where things get a bit more interesting. It's rationalising the denominator. Now, personally, I thought this is a really nice topic in A-level maths because it's basically exactly the same as it is in GCSE maths, and it's good for your algebra skills. So it's a really useful skill to have. So here it says, find the value of x such that 1 plus x over x is equal to the square root of 5, giving your answer in the form a plus b root 5. So all we're going to do here is rearrange for x. So if we times both sides by x, I get 1 plus x equals the square root of 5x. And now if you remember, if you have two terms with x in them, what do you have to do? You have to move them to the same side. So what I'm going to do is I'm going to move the x to the other side over here. So we have 1 equals root 5x minus x. Factorize the x. So now we have, depending on how you want to word it, but there's a few different ways you can write this, but this is probably the most simple way. And divide it over to the other side. And now you might think, oh, there you go, we're done. However, look at the answer. It needs to be in the form a plus b root 5, where a and b are rational numbers. Now, keep in mind, and this actually does confuse a lot of people, even though it says plus here, it can be a negative sign. Why? Well, let's say a was 1 and b was minus 1. Minus 2, let's pick. Then we would have a, which is 1, plus minus 2 root 5. That's how they would expect it, right? So it's still technically a plus. But they can't put a minus b root 5, because if it's a positive number, it'd make it negative, and if it's a negative number, it makes it positive. It doesn't make sense, right? It's way easier. It makes more sense to write it with a plus instead. So just keep that in mind. So, what do we have to do? Well, the problem here is that we have an irrational number on our denominator, which you can't have. Surds are always irrational because they go on forever. Now, could you enter this in your calculator? Sometimes. But other times, it just gives you a decimal. So I'm going to assume that our calculator is broken, okay? Because that makes my life a bit easier in terms of demonstration. What do you do? Well, you just times the top and bottom of the fraction by the exact same thing as the denominator, except you flip the sign that is between the two terms. Now, it doesn't matter if the square root is first, so the surd is first, or the number. You always flip the sign in the middle, okay? And the reason why this is really important is some people say, because normally you'll have something like 1 over 1 minus root 5, right? Like normally the surd is second. So they'll say, oh, you flip the sign in front of the surd. No, it's always the sign in the middle of the denominator, okay? And the reason for that is because we don't actually care about the sign of the surd. What we care about is getting rid of the cross multiplied value. So for example, if I were to now write this out, obviously the top is just root 5 plus 1. That's fairly simple. The bottom now becomes this, although I have flipped the order. The reason why we do this and flip the sign is to get rid of the terms which will cross multiply. It gets rid of the plus root 5 minus root 5 problem that we have. So that equals, so root 5 plus 1 over root 5 times root 5, which of course is 5. Then you're going to have plus root 5 minus root 5, which is the whole point of doing that in the first place. And then you'll have plus 1 times minus 1, which is minus 1. So that equals, if we write it in the form here, it's actually 1 plus root 5 over 4. Now, if you notice, it doesn't say a and b are integers, it says rational numbers. Fractions are rational numbers. So the actual solution is a quarter plus a quarter. It also doesn't say anything's wrong with having the numbers be the same. So this is A and that is B. Completely and utterly fine, because again, rational numbers are just numbers that don't go on forever if you'd like. So normal fractions like a quarter, a half, a fifth, all rational, and they can be positive or negative as well, all rational, and they can be the same. No reason why not. So moving on to this next one, this is a more kind of common rationalizing the denominator question. Again, all you do is you times top and bottom by the denominator, but you flip the sign in the middle. Okay? I'm not even looking at like what it is exactly. Okay? And now we can expand it. Now, again, you can have surds in the numerator. It's just the denominator that's the problem. So I like to write it out in brackets first, just to make it nice and neat and proper. If you're rushing, you may make a mistake, so it's good to write it out. I mean, you guys have seen me make mistakes, so you know that is an issue. And again, all this is expanding brackets, which should hopefully be okay. So 5 times 2 in the numerator is 10. Then we have 5 times root 3, which is plus 5 root 3. Root 3 times 2, which is 2 root 3. Can you do the thing where you simplify in one step like I did before? Yeah. So I could have done 5 root 3 plus 2 root 3 is 7 root 3 straight away. I just didn't do it for the sake of, not simplicity, but just to make it really, really rigorous. Root 3 times root 3 just cancels out the root 3 and it equals 3. Now, again, because I'm worried about your actual mathematical understanding of why that is, I'm going to explain why now. Because, again, with A-level maths, it's really important you understand the whys of maths. So, if you do root 3 times root 3, you actually times the things inside the surd, and it gives you square root of 3 times 3, which is square root 9, which of course is 3. So it does always cancel out the square root, that always works, but that's the reason why. It's like when we simplify surds and we split it up, you know how we do root like 3 times, I don't know, 12 or whatever, and we split it up? It's the same thought process there. So, the line, then we have 2 times 2, which is of course 4. Then we have minus 2 root 3 plus 2 root 3, so that's nothing. And then we have minus root 3 times plus root 3, but we've already established root 3 times root 3 is 3. So minus root 3 times root 3 should just be minus 3. So that makes it, so 10 plus 3 is 13, plus 7 root 3 over 1, which of course is just 13 plus 7 root 3, which if you look at the answer, it says show that it equals this, which it indeed does. And I just want to point out again, with A-level maths in particular, you have a lot of show that question. So they give you the answer, you just need to work out how to get there. So showing your work is very, very important. It's not just, but I got the right answer, I should get 6 marks. They give you the right answer, that's not the problem. You need to get to it, that's the kind of meat and veg of the paper. And it's also so you don't lose out on further marks. And lastly, but certainly not least, we're going to do the exact same thing again, but for this one. What if there's a 2 in front of the root 2? Guess what? Makes absolutely no difference. You do the exact same thing. You flip the sign in the middle of the denominator. Okay? Exact same thing as usual. So again, I'm going to write it out in terms of, oh god, that was horrifying. In terms of brackets. And actually, there is another benefit for me choosing this question, which I'm going to show you right now. So 2, that's all good. And then again, we're going to have 1 times 3, which is 3 in the numerator, right? 1 times 3. Then we have, of course, 1 times minus 2 root 2 is minus 2 root 2. I think we're all fine with that. Minus root 2 times 3 is minus 3 root 2. That's all good. However, doing root 2 times minus 2 root 2, I've seen so many students get this wrong, which I actually get, by the way. I completely get this. Now, here's what I would do, is I would split it up. So first of all, we have minus and a minus. That will become positive, so we can cross it out. The next thing is I'll do root 2 times root 2. It's not 4. I've seen a lot of students write that it's 4. Root 2 times root 2 would be 2 because it cancels the square root. Okay, so that'd be root 2 times 2, which equals root 4, which of course is 2. So this becomes 2 times 2, which is 4, because we have an additional 2 in front. Okay, so the root 2 times root 2 gives me 2, and then I'm timesing that by 2. So can you see where people make mistakes? Really common, and honestly, I don't blame students for making mistakes like that. I've seen everyone do mistakes like that. I've done mistakes like that. Completely natural. And again, 3 times 3 is 9. Then we have plus 3 times 2 root 2 minus 3 times 2 root 2, so that cancels out. And then we have 2 root 2 times minus 2 root 2. Well, this is going to be very similar, right? So we have 2 root 2 times minus 2 root 2. Well, first of all, our answer is going to be negative. So I'm going to just get rid of that negative sign now, because I've already done it. 2 times 2 gives me 4. And then we have root 2 times root 2, which is 2. So that equals minus 8. Okay, that's how I would do it, just to make it super rigorous in my mind. So we have 3 plus 4, which gives me 7. Then we have minus 2 root 2 minus 3 root 2. Again, the root 2's just act like x, so it's minus 2x minus 3x. It's minus 5 root 2 over 1, which of course is exactly what it says in the question. There you go. Nice and easy. Well, it's not easy, right? It takes a lot of practice. So I hope that was really useful to you. Just so you know, I am going to be releasing these periodically, ideally one a week, but who knows if that's going to actually occur. But in the meantime, I'm going to leave the playlist for all of my other A-level maths videos, okay? And it's going to contain all of the live lessons. However, there are actually even more videos on my channel. Like I have a introducing proofs series, which is proof by deduction, which is a very unique part of A-level maths that you have to start getting good at. I know you may remember proofs from GCSE, but these take it a step further. They're a bit more nuanced and requires a new level of kind of understanding and thinking. But I will leave in the description a link to all of my live lessons that I did for about 3 or 4 months last year. But yeah, go easy on me. They're a bit, they're not as high quality as you are used to, but I think that they're still somewhat useful, hopefully.